Okay, section 3.4, mixtures and pure substances. So a pure substance always has the same composition. So elements and compounds both qualify as pure substances. So water, pure water, not the stuff that's coming out of the tap or that's in the river. Pure water, every single particle in there is the same. H2O. So that's a pure substance. All the particles are the same. Now that's a compound. It can be taken apart into hydrogen and oxygen. But as water, it's always in that same ratio. Carbon dioxide, always 2 oxygens for every 1 carbon. Hydrogen gas is always 2 hydrogen atoms bonded together. Elements, gold is an element. Pure gold is just got gold atoms. Always has the same composition. If you take our tap water and purify it so it's just pure water, and you take water from the Nile River in Egypt and you purify it so it's just pure water, those 2 substances are chemically identical. They are absolutely identical because the composition is always the same. A pure substance always has the same composition. And that's in contrast to a mixture. A mixture has variable composition. The composition can be different. So wood, wine, coffee, these are examples of mixtures. I personally don't drink coffee. I tried the other day just because it's just such a good concentrated form of caffeine and much cheaper than Rockstars and Monsters. But I just cannot stand the taste of it. My husband loves coffee. He likes his coffee strong and black. 4 heaping tablespoons of coffee for 2 cups of water. No sugar, no cream, okay? And other people would use like 1 level tablespoon of coffee for that much water. It's a mixture. The composition can vary. It's going to vary from place to place, right? Is the coffee at Starbucks always exactly the same? Yeah, but I mean, like if you get the same thing at your Starbucks and somebody else's Starbucks, is it going to be exactly the same?
It should be, but it depends on who's making it.
It depends on who's making it, right? So yeah, in theory, yeah, we're following the same procedure and it should be the same and we're trying to make it the same, but it probably can't be exactly the same, right? But water, pure water is always exactly the same. So a mixture, the composition can vary. You could have a little more coffee, a little less coffee. Wood, the composition of wood varies even within the same tree. Parts of the wood are going to be harder than others. The composition of it is going to vary. Wine is going to vary. Wood, well, if you take a piece of wood, it's going to have like knots in it, and it has bark. And so where the knots are, the wood is much harder. The composition of it is different where the knot is. And you can actually see it because it has a grain. And so it's got individual cells, and they're different. They vary in composition. And wine is going to vary in composition. Some wines are sweeter, some have more alcohol or less alcohol in them. It's not a pure substance because it's a mixture of different things. The important thing in the mixture is the composition can vary.
Is it still like a physical property? Would we consider a physical property like in the wood? It's makeup, how it's put together, like you said, where the knots are, but
it's harder at the knot, and so the hardness of it is a physical property, and its physical properties are varying from place to place then. The physical properties of a mixture will vary depending on its composition.
The chemical composition of those 2 different hardness are different though, right?
Well, hardness, a mixture has variable composition, and that varied composition may also affect its chemical properties. Different kinds of wood burn differently. Hardwoods burn slower and hotter, and softwoods burn very quickly and don't give off as much heat, and so that affects their chemical properties as well.
could could the thing that be affected by it, say you have a tree that has a lot of water, that's gonna affect its composition.
Right, you take a branch and it's attached to the tree and it has water in it, right? And then you cut the branch off and leave it out in the yard. And the branch dies and water eventually evaporates out of it and it dries out of it. Well, the composition of that branch has changed, right? And that can't happen with a chemical, a pure substance. A compound or an element, always the same.
So it'd be like air,
Air is a
compared
mixture.
Compared to O2.
Right. Oxygen, pure oxygen gas, every single particle, O2. The air in this room has oxygen in it, but it also has nitrogen and argon and other things, carbon dioxide.
What?
Yes, there's argon in the air. Horrors. And you just drank dihydrogen monoxide. Are you afraid? It's a chemical. He's drinking chemicals. Yeah. So mixtures can be separated into pure substances. So a mixture is going to be, it could be two different elements mixed together. Alloys like brass and steel are mixtures of metals. And they can be separated. Okay? You put sugar in some water, you've made a mixture. You could put a little bit of sugar, you could put a lot of sugar. The composition is variable, but that can be separated. Now, sometimes separating it is a little tricky, but like sugar and water, if you just let the cup sit there, eventually the water will evaporate and you'll be left with the sugar. You can separate it. So a mixture can be separated into two or more pure substances. And then we take those mixtures. We already talked about the two different main categories of pure substances, elements and compounds. And then we can break mixtures into two categories, homogeneous and heterogeneous. Homogeneous is the same throughout. We use a lot of prefixes. Okay, this prefix homo means the same, hetero means different. So homogeneous is the same throughout. It's going to have visibly indistinguishable parts. If you look at the top, the bottom, the middle, the sides, it's all going to look the same. Another word for a homogeneous mixture is a solution. Examples, it doesn't vary in composition from one region to another. So the composition at the top, composition at the bottom, it's all going to be the same. So you take that cup of strong coffee that my husband loves, and the top of it tastes just the same as the bottom of it. Nasty. Yeah. It's just horrible. So we'll finish up this homogeneous and then we'll stop. Homogeneous examples, air. The air is generally homogeneous. Brass is a mixture of different metals. It's homogeneous. Table salt stirred into water. The water dissolves the salt, and the top is salty, the bottom's salty, the middle's salty. It's all the same. So we'll start here next time.